Here we have another question of application of derivative, which is again related with the business. The question is saying here, the total cost CX is representing here the cost in dollar associated with the production of X units of an item. Means it's a factory which is producing some products, and CX is giving the cost of production when you produce X amount of products, X units of product. All right, so this is the relation, this is a function which gives you the cost, right, of production. Find the marginal cost when 17 units are produced. So we need to find out the marginal cost, not the cost of making 17 product. Cost of making 17 product, you can simply put here in the place of X, you can put 17, and that you'll get a number, and that is actually the cost of making 17 product. But we need to find out your marginal cost. And the question is further illustrating here as where by the marginal cost we mean that instantaneous rate of the change of the total cost at any level of output. So the marginal cost is something like this. Like if you produce let's say 10 products, let's say the cost is $10. But if you produce 1,000 product, the cost may not be the 10,000. It may be less or maybe more. But in most of the cases, the price becomes less when you produce that into the mass. You know, when you go to publish let's say a visiting card, if you say, hey, I just need 200 visiting cards, he may charge you a lot. But if you say, hey, I need 20,000 visiting cards of the same type, then definitely the cost will be less, because when you do something in huge amount, then that times the cost gets reduced. You know, so this is how, I mean, how the cost varies as you increase or decrease the number. You know, X is just a variable. If you put X amount, if you produce X amount of things, then this relation will give you the total cost to produce that X amount of products. All right, and we need to find out now the marginal cost. So marginal cost means what is the exact rate, you know, at a particular point, at a particular output. Let's say you want to output here 20 products. So when you output 20 products, what is the rate of the cost? You know, so this, you know, this DC, you know, this cost DC over the dx will give you the cost, you know, exact cost. What is the rate of the cost for 20 products? You know, that will give you the rate, actually the instantaneous. That's why it has given the instantaneous rate of the change of the total cost. So what is the cost when you produce 20? You know, what's the rate for 20 products? And if it is in the case of 20, it is this, right? If you produce just 10, it may be something different, so keep in mind. All right, so basically it is a function something like this. You know, if it is x-axis and if it is y-axis, all right, let's say and this is your product. All right, this is your product which is representing x, and this is your cost which is increasing. So as the products is increasing, you know, individually it may reduce, but as a mass, you know, so when you increase the products, definitely the cost will go on increasing. Let's say it's just a rough diagram. All right, so when you produce more amount, definitely the cost will be more and more, but may not be in the same ratio, maybe a little less. As I told you, like if just like I shared, let's say if you produce 200 visiting cards, he's charging you $1,000. But if you produce 20,000, then he may not charge you 100,000. You know, he may charge you less than that, because his cost gets less as you increase the amount. You know, but as a whole, like as you increase the products, definitely the cost will be more. All right, in that way of understanding. So here we need to find out, you know, when the product is, let's say when the product is 17. So at this times, how is this graph changing? How is dc over dx? That we need to find out. At this particular point, how is the cost changing as I change the product? All right, so at this particular time we need to find out the rate dc over dx. All right, so this rate is actually nothing more than the differentiation. All right, derivative. All right, so we have to let's first differentiate this given function. Our cost is given by the relation 0.007 x cube minus 0.003 x square plus 15x plus very little space here. Okay, so let's differentiate both sides with respect to x. So it will be dc over dx. So when I'll differentiate, it will be 0.007. It's a constant quantity, and derivative of the x cube, it is 3x square, and again 0.003, and again here derivative of x cube, that is 2x, and again derivative of 15x, that is 15. All right, and derivative of 4000, that's 0. So finally we get the rate dc over dx as now 7 times 3, so it will be 0.0 21x square. Again, this 3 times 2, so it will be 0.006x plus 15. All right, this is the simple rate. Now what is the exact rate when this x equals to 17? What is the marginal cost at x equals to 17? This is actually marginal cost, right? Keep in mind, this is marginal cost. Okay, even I don't know more about the business, but according to the question, I'll read, you know, the thing I have been given here in the question. According to that, I'm explaining. Well, so now what is this dc over dx? So it's simply 0.021 into 17 square minus 0.006 into 17 plus 15. All right, I wish to use the calculator, it will be faster than my mental calculation. So it's 0.021 times 17 square and then minus 0.006 times 17 and then plus 15. That's result to 20.967. all right, it's 20.967. all right, this is actually the cost given by the calculator. So you see, this dc is the dollar, as the question is saying already, you know, that the cost cx is given in dollar, right? So it's dollar, right, dollar per, and x is the product, all right, is the product. So $20.967 per product is or simply you can say now the marginal cost, exact marginal cost at 20 is simply you can remove the products also. For 17 products, marginal cost is $20.967. all right.